Hello everyone and welcome to this new video on leveling. Today I'm going to go through the heights of collimation method that's used in leveling to calculate the reduced level of the unknown points. I will explain this method through a solved example. In this example I will let you know how to make the bookings, the back sites, foresights and intermediate sites, and also how to do the calculations of all of the unknown reduced levels. So let's get started. Before we start, I would like to mention that there is another video on leveling which is called Introduction to Leveling. It would be very useful to you if you haven't watched that yet to watch the first video, which is about the principle of leveling, equipment used in leveling, and more importantly I explained in details different kinds of readings that we are going to use today, like the back sight, foresight, intermediate sight, change point, these terms, what each term of them means. So it's useful to watch the introduction to leveling video before you watch this one. Now here guys, the principle of height of collimation method is very simple, which is about just calculating the height of this line, which is called the line of collimation. So this is the level, the instrument. Okay, so in this method first we are going to calculate the height of this line. In some references you will see the term the height of instrument as well, which is the height of the center line of the level, which is this line guys. So in this method we are going first to calculate the height of collimation line, this line, and then we are going to calculate the reduced levels of the unknown points. For example guys, here let's say that this is the leveling staff here. Okay, to calculate the elevation or the reduced level of the unknown point A, this one, starting from a known point, this point which is the ordnance benchmark, which has an elevation or reduced level of 60.270 above ordnance datum. We are going to set up our level between the benchmark and point A, and then we will locate the leveling staff here over the benchmark. Okay, and then we are going to make this reading. In this case the reading is 0.561 from the ground to this point here on the leveling staff. So now we have this, the height of this line, which is the reduced level 60 plus the reading here. So in this case it is 60.270 plus 0.561, which is 60.831. This is the height of the collimation line. This is the height of this line guys, which is 60.831. Okay, now we have the height of this line. How to calculate reduced level of point A? When we say reduced level or elevation of any point, that means the ground. Okay, we need the reduced level of the ground guys. So for point A, for example, we need the elevation or the reduced level of this point here. So let's locate the leveling staff over point A. Okay, let's turn the level towards the staff and make this reading here. This reading in this case is 1.334. So now we know that the reading here 1.334, and we know that the height of this line is 60.831. Simply 60.831 minus this reading 1.334 will give us the height of A, or the reduced level of point A. So 60.831 minus the reading over A, which is 1.334, which equals 59.497 meters above ordnance datum. So I would like to mention again guys, if you don't understand these terms, AOD, the back sight, staff reading, okay, All of these were explained in the first video, so I would like to advise to stop now and go watch the first video, which is called Introduction to Leveling, so that you can understand this one better. Yeah, so let's continue. Okay, I will explain this in a different way. Again, the principle of height of collimation method. Let's say that you have a topography like this. For example, this is ground here. Let's say that you have a benchmark with known elevation. For example, we have this point here. Let's say this is a benchmark with known elevation. Let's say this elevation or reduced level is 100 meters above ordnance datum. And then we've been asked to calculate the reduced level of, for example, points A and B. Let's say this is the first point that we have to calculate its reduced level. Let's call it point A, and this is point B. How to calculate the reduced levels for A and B? They are unknown. If you know the reduced level of the benchmark here. So the equipment that you need, of course, leveling staff and level. First, you are going to set up your level somewhere between the benchmark and point A, for example. So here, somewhere between the benchmark. So this is my level here, set up. I will locate the leveling staff over the benchmark, and then I'm going to sight the staff to make a reading here, and this reading is called back sight. Always the first reading when you set up the level over a benchmark or a change point, it's called a back sight. So the back sight here, let's say in this case it's 1 meter. So the reading over the staff, it's here 1 meter. So that means from the ground to this point here, it is 1 meter. So now what is the height of the center line of the level? This line here, it is 100 meters, the benchmark reduced level, plus the reading from here to here, which is 1 meter. So the line of collimation, this line, now its height is 101 meter. Now let's locate the leveling staff over point A. Let's stand the level towards the leveling staff and make a reading here. Let's say that this reading is 2 meters from the ground to this point. Let's say it's 2 meters. Now our aim is the elevation or the reduced level of this point of the ground. What would be the reduced level of A in this case? It would be the height of collimation, which is 101 meters. So the height of this line here, 101 meters, minus this distance, which is 2 meters. So it would be 101 minus 2 meters, which is 99 meters. So this is the principle of the height of collimation method. And this is called foresight. Here it's called backsight. And if we need to get any point between the foresight and backsight, let's say this point here, point C, and this point, point D, these are called intermediate sights. We will locate the staff over them, and then we will take away the reading from here to here from the height of collimation, which is 101 in this case. Now let's say that we have done from this station, we are going to move our level to the new location here between A and B. Now I will set up the level here somewhere between, roughly between A and B. This is my level, okay, and then I'm going to sight the staff over point A to take the reading. Now because we have changed the location of the level from here to the new location here, so the height of this line, of course, this one, is different from the height of collimation here. Because of that, when you change the level location, you need to recalculate the height of collimation in the new location. We have calculated the elevation or the reduced level of point A, which is 99 meters. Let's say that you have sighted the staff here over point A and the reading was, for example, 0.5 meters. Here 0.5 meters. So what would be the height of collimation in this case? The height of this line? It would be 99 plus the backside reading, which is 0.5. So the height of collimation in this case would be 99.5. So now we have calculated the new height of collimation, which is 99.5. How to calculate the reduced level of point B? We are going to locate the leveling staff here, turn the level towards B, make a reading here. Let's say that this reading is, for example, 3 meters. So what would be the reduced level of B in this case? It is the height of collimation, which is 99.5 minus the reading over B, which is 3 meters, and in this case it would be 96.5 above ordnance datum. So this is the reduced level of point B. So this is simply the height of collimation method. So I can summarize this, guys. Using the height of collimation method, you need first to calculate the height of collimation line, which is the benchmark reduced level plus the reading, the backside reading over the benchmark. And then you are going to take away from this height of collimation any reading for point D, C, A, whatever. And when you change the location of the level from station 1, for example, to station 2, you need to calculate the new height of collimation, because we have a new setup of the level, so we have a new height of collimation because we have changed the location of the level at this, in this example, point, change point A. Okay, and then we will calculate the new height of collimation, and from this height of collimation we are going to take away the staff readings of the 4 sites, and if we have intermediate sites here or here or here, we can take away from this height of collimation to get the reduced level of these points. Okay, so let's explain this in a different way using a solved example. To use the height of collimation method, you need to arrange a table like this. The first 3 columns in this table, these 3 columns, these are the readings. Yeah, and these 2 columns here, these are the calculations. To calculate the reduced level, which is our aim from this method, to calculate the reduced level of the unknown points. So in this case, we have the first station of the level here. We set up the level here, guys, and this is the benchmark. Its elevation is given 60.270, and then we located the leveling staff here. We've done a reading, a backside reading. Always the first reading when you set up the level, it's called a backside reading, and this is the reading here. This is the ordnance benchmark line. On this line, the backside reading should be written here, which is 0.561. This is the first reading, and then we are interested in points A, B, and finally C from this station of the level. So let's move the leveling staff to A, locate the leveling staff here, and then collect the reading here. Let's say it is 1.334. I will write it down here. This is point A. On the same line for point A, I will record the reading for the intermediate site. This is intermediate site, and it is 1.334. The same for point B. I will locate the leveling staff here, and then turn the level towards B and then collect the reading, which is 0.911 in this case here. And finally I will locate the staff over C and then take the reading, and this is a foresight because it is the last reading from this station of the level. Okay, so the first reading is a backsight, the last reading is a foresight, and between them intermediate sights. In this case we have the first reading over the benchmark backsight, the last reading over C foresight, between them over A and B intermediate sights. Backsight, these two are intermediate sights, and this one is foresight. Okay, now at this point C, we will change now the location of the level from here to station 2 here. We will move the level from here to here. Because of that, we will call station C as a change point, because we changed the location of the level after this point. Okay, so this is a change point. Now we will set up the level here, locate the staff over C, and then collect the first reading from this new location. The first reading from any location is a backsight. Now a backsight over C, we will write it here. Backsight over C on the same line for C. This is the line for C. This is the foresight from the first station here. This is the backsight from the new station here. Now locate the staff over D, and then this is intermediate sight, collect the reading and then write it down here. And then over E, locate the leveling staff over E and then collect the reading 0.831, write it down here. And finally last point here, point F, locate the staff here and then collect the reading, and it is foresight because it is the last one, and write it down here. This is the line for C and this is the foresight over C. Okay, by doing that we have completed the readings or the measurements that we will use to do the calculations. Okay guys, now to summarize the measurements or the readings, when you set up your level, the first reading is called backsight, the last reading is called foresight, and between them intermediate sights. How to make a reading, this is explained in my last video, Introduction to Leveling. If you don't know how to make this reading 0.561 on a leveling staff, please do have a look at the Introduction to Leveling video. Okay, so now we change the location of the level from here to here. We set up the level. The first reading is backsight, the last reading is foresight, and between them intermediate sights over F and D. Okay, so and this is here in the table, the backsights here, foresights here, intermediate sights here, and there is a line for each point, the benchmark A, B, C, D, E and F. At point C, as you can see, we have two numbers. Foresight, this one, which is from the first station, from here, from this first station. When we sighted point C, we have collected this reading 0.521. This is a foresight because it is the last reading from the first location of the level. Okay, and then when we move the level to the new location, location 2, we set up the level, we sighted the leveling staff over C, and then we collected this reading. It is a backsight because it is the first reading from this new location of the level, and we will write it here on the same line for point C. So these are the measurements. Now, how to do the calculations? From any location of the level, you need first to calculate the height of this line, the height of collimation line. So the height of collimation is always, the height of collimation is the reduced level of the benchmark plus the backside reading. So this is the height of collimation. The reduced level, the non-reduced level, plus the backside reading. In this case, this is the reduced level of the benchmark, 60.270, and this is the backside reading here. Okay? So, and the height of collimation in this case is 60.831, which is this number plus this one. 60.270 plus 0.561, which is 60.831. So this is the height of collimation for station A. Now from this height of collimation, we are going to take away this reading from here to here to get the ground reduced level. From the same height of collimation, we are going to take away this reading, which is 0.911, to get the reduced level of B. From the same height of collimation, we are going to take away this reading from here to here, which is 0.521, to get the reduced level of C. Okay? So first, to calculate the reduced level of point A, from this height of collimation, guys, we are going to take away this reading, the intermediate site over A, and then we will get the reduced level of A. So 60.831 minus 1.334, it would be 59.497. Now to calculate the reduced level of B, the same thing. From this height of collimation, we are going to take away the intermediate site over B, which is this one, 0.991, and then we will get the reduced level over B, which is 59.920. So 60.831 minus 0.911 will give us 59.920. Now the reduced level of C, the same. From this height of collimation, we are going to take away the staff reading over C, which is 0.521, to get the reduced level over C here, which is 60.310. So this is the reduced level of C. Now C is a change point because we changed the location of the level after this point from here to here, and from the new location of the level we cited C again, and we collected this backside reading, which is here. Because of that, we need to calculate the new height of collimation, which is the reduced level, this one, of C plus the backside over C. So 60.310 plus 2.338, and it would be in this case 62.648. So this is the new height of collimation, the height of this line. Yeah, and from this height, guys, now 62.648, we are going to take away this reading to get the reduced level of D, to take away this reading to get the reduced level of E, to take away this reading to get the reduced level of F. So now we are going to calculate the reduced level of D, E, and F, which is the height of collimation minus the intermediate site or the foresight. So, and this is the height of collimation, 62, minus the intermediate site, which is for point D. This is the intermediate site for point D. So 62 minus 62.648 minus 1.219, it will give us the reduced level over D, which is 61.429. The reduced level over E, which is the height of collimation, this one, minus intermediate site over E, 0.831. This will give us the reduced level over E, which is 61.817. And finally, the reduced level over F, the last point, which is the height of collimation, 62.648 minus 4 site over F, which is 1.721, and this will give us 60.927. This is the reduced level over F. Now by doing that, we've done all the calculations. We've calculated the reduced levels of all of the unknown points A, B, C, D, E, and F, starting from one known point, which is the ordnance benchmark. So this is simply how to use the height of collimation method, guys. It is an easy one, it's not complicated. In the next video, I'm going to do some calculations check. Now we've done the calculations, but are our calculations accurate or not accurate? And also we've done some readings. Are these readings that we've done here? Now we've done all of these readings. Are these readings accurate or not accurate? This is what I'm going to cover next video. And also we've done the calculations here. Are these calculations correct or not correct? So I'm going to do some calculations check and accuracy check. This is the topic for our next video. I hope that was useful today. Thank you very much for listening and see you soon. Bye.